Is the universe infinite? Does it have a boundary? And if so, what would you see if you went there? Today we know that the universe had a beginning 14 billion years ago and that it's been expanding ever since. But something that's expanding should also have a limit, right? Well, it sort of does. Information can't travel faster than light. That means that we can only see parts of the universe whose light has had time to reach us in the last 14 billion years. When we look outward, what we see is a sphere centered on us, the observable universe. But it gets a bit more complicated because the universe has been expanding. We know that the most distant things whose light we can see are actually 45 billion light years away from us right now. So the observable universe is a sphere with a radius of 45 billion light years. It contains around 200 billion galaxies, each with hundreds of billions of stars. So for us, there is an edge. We are looking at the past until there is just no past left. This edge is really more like an edge in time and, in a sense, meaningless. The real universe is definitely larger than what we can see. But how much larger? There are two possibilities. Either the universe is really large but finite, or it's truly infinite. A finite universe means that if you want to fill it with ice cream, you can do it. You need a lot of ice cream, but it is a finite amount. But that leads to a strange problem. Such a universe should have an edge, a cosmic wall where space ends. And if there is a boundary, there should be something beyond that edge. But the universe, by definition, is all there is, so how could there be something beyond all there is? Does the idea of something outside of everything even make sense? Except, of course, there is a physics hack. You can have a universe that has no border, but that still could be filled with a finite amount of ice cream. What if the universe is truly finite? Imagine an orange and a really tiny ant. The ant can only see a small part of the skin, just as you can only see a small portion of the universe. But if the ant starts walking, it will eventually walk around the whole orange and return to its starting point. So the skin of an orange is not infinite, but it doesn't have a boundary. The universe is not like the skin of an orange, but it could be very similar. Instead of a sphere, it could be a hypersphere, where 3D space is curled on itself. This is impossible for your brain to visualize, unfortunately. But the point is, no borders, no outside of the hypersphere from our human ant perspective. Our whole 3D space is like the peel of the orange. If you were aboard a spaceship flying in a straight line, you would eventually come back to Earth. How does any of this make sense? The actual physics is complex, so we have to simplify and lie a bit here. But in a nutshell, it all boils down to gravity. The way it works is that mass creates gravity by bending space-time. This bending is the strongest where the mass is, but sort of stretches on forever, like a very mild tension in the fabric of space-time itself. This could bend the whole universe in a way where it curves back on itself, which then forms the hypersphere. If you find this perplexing, we are with you. If the universe happens to be a hypersphere, how could we determine its size? On Earth, we can see things disappear below the horizon, which helps us calculate the Earth's dimensions. Scientists attempted to find some sort of universe horizon that would reveal the scale of the cosmic sphere, but didn't find anything. This means that if the universe is a hypersphere, it needs to be so vast that, from our perspective, it looks like we are living on a flat surface. For this to make sense, a hyperspherical universe should be at least 1,000 times larger than our observable portion. It could be a trillion times larger for all we know, but not smaller than that. Some scientists thought all of this was too straightforward and proposed a wilder option. The universe could be like the frosting of a donut. A hyperdonut, also impossible to visualize for your brain. This too means that if you travel in a straight line, you'd return to where you started. But with fun complications, in a hyperdonut universe, there is not the same amount of stuff in every direction. If two spaceships fly in different directions, one could return to the start way earlier. This also means that light from faraway galaxies would do fun and confusing things, creating a sort of cosmic Hall of Mirrors effect. We could see faraway objects in two places, but not just that, we would see them at different moments in time, because their light would have taken much longer to travel in one direction than the other. You could see a star being born in front of you and see that same star die on the opposite side of the sky. Why? How large would such a hyperdonut universe be? Well, because of its strange geometry, this is actually the smallest possible universe, potentially just a few times larger than the observable universe. But it could also be vastly bigger. We don't know. Okay, so much for finite universes, but what if it's truly infinite and space goes on forever? What would that be like? What if the universe is truly infinite? Actually, the cosmological model used by most scientists describes an infinite universe. We mostly use it to calculate what happens inside our observable chunk, but if taken literally, it predicts an infinite universe. An infinite universe goes on, well, forever, with no boundary anywhere, also impossible to visualize. Wherever you look, you'll find more and more stuff in every possible direction. This kind of breaks our brain a bit for a few reasons. First of all, if the universe is infinite, is it also eternal and has been there forever? Was there a time when there was nothing everywhere, and then there was something everywhere? Well, we don't know, but we have a lot of evidence for the Big Bang, so it really seems like the universe started at some point in the past. But wait, since the Big Bang, the universe has been expanding. How can an infinite thing that is everywhere become even bigger? Cosmic expansion just means that the distance between galaxies is growing with time. Even an infinite space can become bigger. Welcome to the paradoxes of infinity. Infinity gets much weirder, though. As you travel with your spaceship in a straight line, you find new galaxies, stars, and planets, new wonders, new weird stuff, probably new aliens and new life forms stranger than you could ever imagine. But after a long time, you might find the most special thing in the universe yourself, an exact copy of you watching this video right now. How can that be? Well, everything in existence is made of a finite amount of different particles, and a finite number of different particles can only be combined in a finite number of ways. That number may be so large that it feels like infinity to our brains, but it's not really. If you have finite options to build things, but infinite space that is full of things in all directions forever, then it makes sense that by pure chance, there will likely be repetition. Although just because something is possible doesn't mean it will actually happen. Maybe the universe goes on forever, but only the boring stuff repeats itself endlessly. Maybe there is really only one you. But if the laws of physics are the same everywhere, then far, far away gas could have given birth to stars and planets, where primitive genetic information could emerge from chemistry. This might have ended up in cells and animals that evolved in really unlikely ways. And eventually apes that learn how to create online videos. It happened at least once, so the chance is not zero. Even if the chance of there being an exact copy of you watching this video right now is almost zero is still a huge number in an infinite universe. Unfortunately, you'll never meet, because almost zero still means the chance is incredibly small. Earth, as it exists right now, is so unlikely you'd have to travel incredibly far to find a second identical Earth, some 10 to the 10 to the 29, a 1 followed by 100 octillion zeros times the size of the observable universe. So far that it kind of means forever far away. Still, in a truly infinite universe, every combination of particles could reasonably not just size its time to stop now. While these scenarios are possible on paper, we've entered science philosophy here. Currently, none of these ideas are testable or provable. If the universe is infinite, we will never know. The reality is, for us, the universe is finite and has an edge, and we can see the edge in time. Everything we can interact with is within the observable universe, and most likely this will remain true forever. Even if this finite universe feels small to you, it's more than big enough to fulfill all the dreams that we and our descendants can ever come up with. Infinitely enough for all of us. While we can't be certain whether the universe is infinite, many fascinating questions do have definitive answers in science, math, and technology. These fields continue to expand our understanding of the cosmos, providing us with incredible insights and innovations. Through the study of cosmology, we have uncovered remarkable phenomena such as black holes, dark matter, and cosmic microwave background radiation, each contributing to our knowledge of how the universe operates. Moreover, advancements in technology have enabled us to peer further into space than ever before. Telescopes like the Hubble Space Telescope and the upcoming James Webb Space Telescope allow us to observe distant galaxies and celestial events, providing data that can refine our models of the universe. These tools have opened new frontiers in our quest to understand the vast expanse of space. In addition to observational technology, theoretical physics offers profound explanations for the nature of the universe. Concepts like string theory and quantum mechanics challenge our conventional understanding of reality, proposing that multiple dimensions and parallel universes might exist. While these theories are still in development and require more evidence, they stimulate important discussions and guide future research directions. Ultimately, the exploration of the universe, whether finite or infinite, drives human curiosity and innovation. It pushes the boundaries of what we know and inspires us to seek answers to the most profound questions. Whether we are deciphering the mysteries of dark energy or contemplating the existence of other intelligent life forms, our pursuit of knowledge propels us forward, making each discovery a stepping stone toward a deeper understanding of our place in the cosmos. The finite nature of the observable universe doesn't limit our potential for discovery and growth. Instead, it provides a vast playground for scientific inquiry and imagination. As we continue to explore, we uncover new layers of complexity and beauty, reminding us that the journey of understanding the universe is as infinite in its possibilities as the cosmos itself may be. Beyond the tangible advancements, the study of the universe also profoundly influences our philosophical perspectives. The vastness and intricacy of the cosmos inspire us to contemplate our own existence and place within it. This cosmic perspective fosters a sense of humility and interconnectedness, urging us to consider the broader implications of our actions on a planetary scale. It challenges us to think beyond our immediate surroundings and recognize the fragile, unique nature of our home planet within the expansive universe. Moreover, the pursuit of knowledge about the universe has practical benefits that extend into our daily lives. Technologies developed for space exploration, such as satellite communications and GPS, have become integral to modern society. Innovations in material science, medical imaging, and environmental monitoring all trace their origins back to space research. As we push the boundaries of our understanding, we simultaneously drive technological progress that enhances our quality of life and opens new avenues for economic growth and development. Did you know that our understanding of space has led to many inventions we use every day? For example, the GPS on your phone, which helps you find directions, was made possible by satellites orbiting the Earth. These satellites send signals to your phone, telling it exactly where you are. Without studying space, we wouldn't have this amazing technology that helps us find our way. Another cool thing about space research is how it helps us take better care of our planet. Satellites in space can take pictures of the Earth from high above, allowing scientists to see how our environment is changing. They can monitor things like deforestation, pollution, and even the health of our oceans. This information helps us protect our environment and make better decisions to keep our planet healthy. Space exploration also teaches us a lot about science and technology. When we send astronauts to space, we learn how the human body reacts to living in space, which is very different from living on Earth. This knowledge helps us understand more about health and medicine. For example, studying how bones and muscles weaken in space has taught scientists more about diseases like osteoporosis, which affects bones on Earth. Exploring space inspires creativity and imagination. Think about all the amazing stories, movies, and books about space adventures. They capture our imagination and make us dream about what else might be out there. Learning about space encourages kids to ask questions, be curious, and think about the future. Who knows, maybe one day you'll be one of the scientists or astronauts making incredible discoveries about our universe. One of the most fascinating things about space is the possibility of discovering other forms of life. Scientists are constantly searching for signs of life on other planets and moons. For example, Mars has been a big focus because it has conditions that might support life, like evidence of water. By studying Mars and other celestial bodies, we hope to find out if we are alone in the universe or if there are other living creatures out there. This quest to find life beyond Earth sparks curiosity and makes us wonder about the endless possibilities in the universe. Additionally, space exploration helps us understand our own planet better. By studying other planets and their atmospheres, we learn more about Earth's weather, climate, and natural processes. This knowledge can help us solve problems here at home, like predicting weather patterns more accurately or finding new ways to use renewable energy. Learning about the universe not only satisfies our curiosity, but also gives us tools to make life on Earth better and more sustainable. So every time you look up at the night sky, remember that the stars and planets out there hold secrets that can teach us more about our world and ourselves. Finally, the quest to understand the universe ignites a passion for learning and exploration in future generations. Educational initiatives and public engagement in astronomy and space science inspire young minds to pursue careers in STEM fields. By nurturing this curiosity and providing opportunities for discovery, we ensure a continual influx of fresh perspectives and innovative ideas. This cycle of inspiration and exploration not only advances our scientific knowledge, but also cultivates a society that values curiosity, critical thinking, and a deep appreciation for the wonders of the universe. 2 videos about the universe will now appear on your screen to expand your knowledge. Choose one of them to broaden your mind and learn more about this, which is our true home. See you around, friend.